Okay, so let's move on to the third part of this topic on sampling distribution. This lesson will focus mainly on the application of the expected value and variance of the sampling distribution of the mean. So, as you recall, in the two previous lessons, particularly in lesson 1, we are able to learn how to construct the sampling distribution of the mean. And in lesson 2, we are able to determine, or we are able to compute for the expected value and the variance, and consequently the standard deviation of the sampling distribution. And from the expected value and the standard deviation, we are able to affirm what we call the central limit theorem, which guarantees that the sampling distribution of the sample mean approaches a normal distribution as the sample size increases, regardless of whether or not the population or the parent population is normally distributed or not. So, by our concepts of random variable, since every normal random variable can be transformed into the standard normal random variable z, that is exactly what we are going to do now. Since x bar, treated as a random variable for the sample mean, is normally distributed with a sufficiently large sample size, then we can apply the probability distribution of the normal curve, particularly the z table, to find specific probabilities associated to several samples relative to a given population. Let's consider this example. Suppose in a statistics class, the average of the students in a certain examination is 86.2 with a standard deviation of 8. Okay, again, we have a statistics class with the average score in a test to be 86.2 and a standard deviation of 8. We'll look into two questions. What is the probability, for example, that a randomly selected student will score 88 or less? Again, what is the probability that a randomly selected student will have a score of 88 or less? The second question will be, what is the probability that a sample group of 15 students will have an average of 88 or less? Can you see the difference? They involve the same numbers, but in the first question, it's pertaining to a single student with a probability that she or he will obtain a score of 88 or less. On the second question, it's asking about the probability that a sample size of 15 randomly selected from the class will have a score of 88 or less. These two questions will be answered differently according to the parameters and statistics involved. For example, in the first question, the question is, what is the probability that a randomly selected student will have a score of 88 or less? Well, on the assumption, if you look at the problem, the assumption also is that the scores of the students are normally distributed. Okay? So, to be able to answer this first question, we'll look at the given first. The given, 86.2, is actually the average of the population. So, that is mu, the parameter mu, meaning the mean of the population. The standard deviation given is the standard deviation of the population also. It will be denoted as sigma, and that is equal to 8. So at this point, we have mu is 86.2 and the sigma or the standard deviation is 8. Okay, to answer the first question, what is the probability that a randomly selected student will have a score of 88 or less? The usual process, we transform the normal score 88 88 into the standard score or the z value. Remember, how do we transform? The z score is x minus mu over sigma. The transformation formula from x to z is given by z is equal to x minus mu over sigma. So we'll apply that to the value x equal to 88. Again, bring out your calculator. Let us transform 88 to the standard value of z. Okay, so to get the z value, it's as simple as 88 minus 86.2 over 8. Again, it's 88 minus 86.2 over 8. That will give us 0.23. So the standard score of 88 or of x equal to 88 is z equal to 0.23. So in the problem, the question is, we want the probability that x is less than or equal to 88. Okay, so the immediate symbolism of the first question is the probability that x is less than or equal to 88. Now, since we are able to standardize 88 as 0.23, then the probability that x is less than or equal to 88 will be equal to the probability that z is less than or equal to 0.23. At this point, please bring out your z table and look for the probability of z less than or equal to 0.23. Referring to the z table, as you can see, the probability that z is less than or equal to 0.23 will be 0.5190. Again, it's 0.5190. In other words, there is a probability of 51.9% that a student or a randomly selected student will have a score of 88 or less. Now, for the second question, we are interested on the probability that a sample size of 15 will have a score of less than or equal to 88. So how is this different from the first? Well, in this case, we are now talking about a sample group of 15 members and the probability that they will obtain an average of 88 or less. So while in the first problem, our random variable was the random variable x, in the second problem, the random variable is now x bar. Again, the random variable in the second question is now x bar, meaning it's the sample mean. So in symbols, we would translate it as the probability that x bar is less than or equal to 88. Again, it's a probability that x bar is less than or equal to 88. So, we use the central limit theorem. According to the central limit theorem, the distribution, since the parent population is normally distributed, then the sampling distribution of the sample mean will also be normally distributed. So we can always transform into the z value. But this time, the z value will be x bar minus mu over sigma over the square root of n. Remember, according to the central limit theorem, the standard deviation of the sampling distribution is given by sigma over the square root of n. So that will be the standard deviation of the sampling distribution. So the transformation formula this time is now z is equal to x bar minus mu over sigma over the square root of n. So substituting the value, it's going to be 88 minus 86.2 all over 8 over the square root of 15 because our sample size is 15. Okay, so again, get your calculator, compute for the exact value of 88 minus 86.2 all over 8 over the square root of 15. Okay, the z value this time is 0.87. The z value is 0.87. It's different from our z in letter A, which is 0.23. Okay? So this time it's 0.87, and the original problem that where we are interested in knowing the probability that x bar is less than or equal to 88 is now transformed into the probability that z is less than or equal to 0.87. Now again, bring out your z table, look for the probability that z is less than or equal to 0.87. So checking on the z table, the associated probability for z less than 0.87 is 0.8078. In other words, there is a probability or there's a chance of 80.78% that the sample size of 15 that is randomly selected from the class will have an average of 88 or less. So you see the difference. In the first question, there is a probability of 51.98% that a student will score 88 or less. But in the second, we have a probability of 80.78% that a group of 15 students will have an average score of 88 or less. So you see how we use the probability of z and transform from x to z and x bar to z. Just take note that when we are using the sampling distribution of the mean, the transformation to z is x bar minus mu over sigma over the square root of n. As compared to, if you are using the random variable x, it will just be z is equal to x minus mu over sigma. We'll have the last example in a while. And with the assumption that the content of this sachet of shampoo is normally distributed. So we have the mean 10 milliliter or ml and a standard deviation of 1.4 ml. The first question is, what is the probability that a sample size of 12 sachets will have an average content of 11 ml or less? Again, find the probability that a sample of 12 sachets of this shampoo will have an average content of 11 ml or less. So in the symbolism, we are actually looking at the probability of x bar that is less than or equal to 11. Again, we are looking at the probability that x bar is less than or equal to 11. Now for the given, it was already mentioned in the problem that mu is equal to 10, particularly 10 ml, and sigma, or the standard deviation, is 1.4 ml. So we can transform x bar, the x bar is 11, okay? We want x bar equal to 11 to be transformed into the z score. So it's just easy. If you recall what we used in example number 1, z is equal to x bar minus mu over sigma over the square root of n. So again, bring out your calculator, compute 11 minus 10 over 1.4 over the square root of 12. Okay, so what do you get? You should get 2.47. So the standard score for 11 at this point is that z is equal to 2.47. So if you look at the probability problem, we are looking at the probability that x bar is less than or equal to 11, and that is equivalent to the probability that z is less than or equal to 2.47. Again, bring out your z table and locate the probability that z is less than or equal to 2.47. And you should get 0.9932. Again, you should get 0.9932. In other words, we are looking at a 99.32% that a sample of 12 sachets of this shampoo will have an average content of 11 ml or less. Okay, for the next question, what is the probability that these 12 sachets will have an average content of greater than 10.5 ml. Or in other words, what is the probability that this 12 sachet will have more than 10.5 ml content? So it's basically transforming again this score into the standard normal value Z. So again, we apply the formula, bring out your calculator, compute Z is equal to x bar minus mu over sigma over the square root of n. This time, x bar, the x bar that we are looking at is 10.5 ml. So 10.5 minus 10 all over 1.4 over the square root of 12. Calculator? So the value of Z is 1.24. This time we are looking at probability that Z is greater than 1.24. Well, as you learn in the normal distribution, we are looking at the probability of a greater than value of Z. So what we do in the arithmetic of the probability that Z is greater than 1.24 is equal to 1 minus the probability that Z is less than or equal to 1.24. So use again the Z table, find the probability that Z is less than or equal to 1.24, and from that value, we subtract it from 1 because we are looking at the right tail of the distribution. According to the table, the probability that Z is less than or equal to 1.24 is 0.8935. Again, it's 0.8925, I should say. Okay, so if you look at the table, the Z table, the probability that Z is less than or equal to 1.24 is 0.8925. So we subtract this from 1, we subtract 0.8925 from 1, we will get 0.1075, or that is 0.1075. So how do we interpret this? Well, it simply means that the probability that the 12 sachets will have an average content of 10.5 or greater is 0.1075. In other words, there is a chance of 10.75% that these 12 samples of sachets will have an average content of 10.5 ml greater. Okay, so that's basically how we apply the concept of expected value and variance of the sampling distribution. What is important here is you're able to utilize the normal distribution, particularly the Z values, to find for the corresponding probabilities for different sample size or for samples that are randomly selected from the population. So to summarize, when you are interested on the probability that a certain sample will have a mean of a fixed value, all you need to do is transform that mean into the Z-score and find the corresponding probability in the Z table. So whatever the probability of Z will be the probability of your X bar. Okay, so I hope you have a great learning. So please review all the concepts in lesson 1, 2, and 3 and get ready for some other activities that will be provided to you.